I'm Lori Goldman, and I'm here with Sue Kirschman. We're the hosts for tonight and are on the board of First Things First Okanagan Climate Action. This is our 21st Deep Dive Seminar, which we've been hosting monthly since 2020. We feature speakers who bring together different perspectives on climate solutions. And by learning together, we hope to build connections and gain insight into what we can accomplish here in the Okanagan Valley.
When we talk about renewable energy, we generally think about solar and wind and perhaps tidal. Often overlooked is the ground beneath our feet, which is a vast thermal storage device. The term geothermal, which essentially means ground, geo, and heat, thermal, is used to describe a couple of different applications. The first one is conventional geothermal, also called deep geothermal. Geothermal heat can be captured and used to create electricity or to provide district heating for the homes and industries in that area. The second application of geothermal is called geo-exchange or shallow geothermal. In this case, the earth is used as a battery rather than as a heat source. The ground absorbs heat from the sun and stores it year-round at a near constant temperature. In most places on Earth, if you go down 2 to 6 meters below the surface, the ground temperature is a constant 10 to 16 degrees year-round. So shallow geothermal takes advantage of this near constant temperature by extracting heat from the ground and bringing it up into the home during the winter for heating, and in the summer the opposite happens, with the heat being pushed back down into the earth as the house is cooled. Tonight, our guest presenter will explain the ins and outs of how these shallow geothermal systems work. And I'll introduce Jimmy. Jimmy Leask is the Director of Marketing and Business Development at Geotility Geothermal Installations in Kelowna. They are leaders in geothermal energy installation in Canada and the US. And we're very happy to have him here to share his knowledge and expertise.
So a bit of geothermal 101, what is it? So it's heating and cooling method that utilizes the constant temperature of the earth, eliminating the use of fossil fuels and reduces greenhouse gas emissions. So essentially geothermal or geo-exchange systems transfer heat from the ground into the home, like Sue was saying earlier. So we're really just moving energy. We're not creating heat energy. We're moving energy from the ground via a series of pipe networks and pumps within the home. And that heat exchange system consists of that underground piping that circulates fluid through the ground and then into the home, which you'll see on the next slide. There are 3 primary components of a geothermal system: the ground heat exchanger, which is your ground loop, is what we may call it, or underground series of piping. On the inside, you will find a heat pump. This would be very similar to the size or look of a gas furnace or maybe an air source heat pump, which sits outside, but that is your interior mechanical equipment. And then from there, you have your distribution system as you would in any typical home. So whether that's forced air ductwork, hydronic heating through radiant in floor, or fan coils of that sort. So as you can see, here's a little bit of a visual. So if this was a vertical application or horizontal application, you had your heat pump sits inside your home. And that's the wonderful thing about geothermal systems versus air source, is your heat pump's going to sit inside the mechanical room. So the longevity of that heat pump is much longer. But first is your underground pipe network, whether that's vertical or horizontal. As the water circulates, it collects the heat energy from the ground and connects back to the heat pump inside the home. And then inside that heat pump, there's a small compressor or heat exchanger that will then turn that into a forced air or inflow radiant or hydronic heating and cooling, whatever it may be inside your home. So with your traditional gas furnace, you're going to have your furnace, your air conditioner, which sits outside, your venting materials, all your gas lines, your refrigerant lines, and your electrical lines that run outdoors to your AC unit. And outside, you will have your condenser, your pad for the outdoor equipment, and your electrical wiring and weatherproof disconnect for the AC unit. Whereas when you move with a geothermal system, inside you just have one ground source heat pump that's in one box that does your heating and cooling. It does have the ability to put a de-superheater on there, which can supplement your domestic hot water, and a small little pump or flow center within your mechanical room that connects the ground loop to the heat pump. And that is it. There is no outdoor equipment. All of the infrastructure is buried underground, which is wonderful. So you get to eliminate a lot of that outdoor nuisance. Our rigs are custom built, like I said at the very beginning, for geothermal drilling. So we do not use water well rigs and do this every once in a while. We have over 60 full-time staff between our branches, and we specifically concentrate on the technologies that we work with. They're very small drill rigs, and when you're really considering drilling, they fit on we built them on a Ford F550 footprint. And then we also have track rigs, which were even smaller. See, we have one of our guys tying in that below grade header, which would then get stubbed into the mechanical room over here. And then from there, it connects to a flow center that then that marries up between the heat pump and the ground loop, that flow center, and circulates the fluid.